Our next task is going to be to add some random motion and turbulence to the movement of the particles. If you look under the add forces compound, we have the gravity force driving the add forces vector. It's the only one controlling the movement of the particles. In this case, if I right click and insert a new port, so I now have a gravity force with an additional vector. I'm going to actually use a wind force and turbulize its value to drive some kind of a turbulent effect on the particles. So when it comes to forces like wind, we can get the wind force directly from the tasks forces particles forces menu. But in this case, I don't really have a visual icon that lets me see the direction I need to go if I need to just look at my 3D view at a glance. We can use the traditional control objects. If you look under Get Primitive Control Object, we have all of our traditional control objects here. And I'm going to actually get a wind control object, which gives me a visual vector that shows me the direction of the wind effect. So I can actually pull that into my scene and use it to combine with the gravitational force. I'll hit F3 and just drag the wind into the scene. So I have wind now brought in as a 3D vector, and the 3D vector is represented by the positive x-axis. And I'm going to actually turbulize that value a little bit. So I'm going to use a turbulence around the wind vector. So I'm going to be taking the vector of the wind and adding some random kind of turbulent motion to it. So I'm going to turbulize around value. And the value is my base value. And then I can control the variance around it as well too. So I'm going to output the turbulized value into force 2, and I'll just kind of make some room down here. And now I'll play and see what we have. So at first we don't really have too much. We get a little bit of shifting from side to side. So I can actually take out the y-axis because I'm really just focusing on the particles. The particles are moving along their y-axes, and we're getting a bit of side-to-side motion. So I could increase the amount of motion, the amount of turbulence, and if I increase the scale, we can see the particles will kind of tend to follow one another. They'll kind of clump together. Groups of them will start doing the same thing. But I'm going to bring together that turbulence field. So there's very little motion from side to side. And if I increase the strength of the wind, again, you can see they're now blowing away from the z-axis. They're actually blowing away on the x-axis. So I'm actually just aligning the particles now to blow along the positive z-axis. I'm actually going to take the wind velocity down a little bit as well. Take it down a little bit more. There we go. So now you can actually see that the wind is blowing the particles with a slight turbulence in the direction represented by the wind vector. If you had a hard time selecting the wind icon, you can actually just grab it from the Explorer. So oftentimes when we add many forces together, the effect can sometimes start to jitter, if you will. And to control that, we can use a force that accounts for drag, a little bit of resistance in the atmosphere through which the particles travel. So under the Forces menu, we can add forces. We can add a drag force to our add forces compound. Again, I don't have to keep adding inputs on the add forces compound. I can just drag to the new force input, and it automatically creates a new input on release. So if I lower the drag strength, which typically you want the drag strength fairly small, otherwise the particles tend to slow to a crawl. Again, you can see here that they're already doing so. If I set the drag strength to 0.01 or even to 0.001, they tend to retain their initial velocity the closer you get to zero. I find that the simple velocity-based drag is far quicker than using the physically accurate drag. This one is quite taxing on the processor, so I would go with the simple velocity-based drag if you need to. If you can't use anything else. So I'm going to try and increase the drag just a little bit, 0.003. So what you can actually do is this is a nice way to tune the speed of the snowflakes. So if you want really light snowflakes, you can really increase the drag strength, as the increased surface area would slow the snowflakes down. But you can also randomize that strength as well too. In the case of the drag, we can actually take one of the randomized value by range compounds and use it to give a really nice blend between some that are more resistant to gravity with additional drag and others that actually flow quite freely. So we'll go with, say, a drag of 0.09. So actually just hit play here and see what we've got. So I've actually got quite slow particles, which doesn't really help me too much, so I'm going to give it a really small range. Okay, I'm then going to go back into my Turbulence, and I'm going to see if I can't increase that scale a little bit more, just to get the particles moving a little bit. There we go. So we're getting a little bit more drifting. Let's increase that scale. So we're just pulling and pushing the particles, kind of using a noisy sine function, a little further apart. So I'll just increase that turbulence a little bit more. And then if we want to, we can even work with the animation speed to kind of speed up a lot of those transitions. But I really like the slower kind of animation speeds when we're dealing with snowflakes. We'll get a bit more wispiness in here. I find we have more time to kind of savor the transitions in amplitude between the peaks and valleys. So I'm going to take that animation speed down a little bit more, kind of push that movement a little more left and right in X and Z. And let's see if I can lower that a little bit more. As sort of a maximum motion. That actually looks pretty good right there. I'm just going to move the emitter backwards a little bit, simply because the particles are drifting with the wind effect, and we're kind of losing a lot of the particles right here. There we go. So now that we've got the movement of the snow working the way we want, we can focus on adding a few more little touches before detailing the particles in the render tree. So to review, we've combined three forces: a gravity force with a vector on the y-axis with a magnitude of -9. We've taken our wind, which is a physical icon in our scene, that gives us a directional vector, so it gives us a visual on the way that our wind is blowing. And we're turbulizing around that value. So we're adding a little bit of shifting back and forth as it's being blown left to right. And we're just using a small amount to do that, a unit back and forth, unit and a half back and forth on the axis. We've got a wide turbulence scale to allow for a fairly large drift, and a small animation speed to allow for a lot of time to occur between drifts to the positive and negative of this variance. And finally, we've used a drag force with a randomized strength to add a little bit of resistance to the particles, to let the surface area of these snowflake objects hang in the air a little bit longer.